Okay, similar kind of question to the last one. Use the graphs shown to answer the following. Which graph has the largest value for b? Okay, so again, we're thinking of y equals ab to the x. Okay, remember that's the initial value. This is b here. So the large value of b will have the quickest growth rate, and that looks like d to me. You see that? Okay. Now, how about the smallest value for b? Now, the thing about the smallest value for b means, does this mean that 2 is smaller than 4, or does it also mean that 1/4 is even smaller? So this, the smallest value of b, must mean it's got, right, let's take a look at this. Now remember, I'll show this from the last video, 4 to the x and 2 to the x. This will have a quicker growth rate, okay, larger base. But if I reflect it over the y-axis, remember this is 1/4 to the x, this is 1/2 to the x if I change the negative exponent to positive. So a smaller base in the fraction will have a steeper decay. So the steepest decay I see here looks like b. Okay, so I think that that is d and that is b. Okay, I know that something like, if you look at this, f is smaller than e, but a isn't smaller than c. Okay, so let's take a look at the others. Which graph has a large value for a? The initial value, well, right there. Okay, that one there. So that is c. What's the smallest value for a? This one down here. Okay, so that is f. Okay, hope that's okay. Now then, here's a graph. Let's have a look. Write a function describes the transformations. Okay, now then. Okay, if this originally was 3 to the x, well, it looks like it's been flipped. The graph, it shows a dotted line. Okay, the dotted line is the original, of course it is. If I flip it over the x-axis, because now it's upside down, it's got a minus in front. Now it looks, remember, if I flip it over the x-axis, now watch this. This will go down to here. Okay, think about that. If I do this, that's just me flipping it over the x-axis. Can you see that I've therefore moved it down 2? Okay, so possibly that is it. Okay, that's what I can see right now. I flipped it over the x-axis and moved it down 2. Right, how about this one? Okay, this looks like it's been flipped over the y-axis. So again, if this originally was 3 to the x, this is now 3 to the negative x. Okay, because I flipped it over the y-axis. And it looks like I just moved it up 1. Okay, remember it was here originally. Now it's here. Okay, I think that's it. Again, you can always check by putting these into Desmos and see if that's what you see. Right, if we start with a function, right, the function results from the transformations. So this is hopefully straightforward. If you shift something up 5 units, 3 to the x just plus 5. Right, shifted right 6 units, so that's 3 to the x. Now think about it, it's going that way. Remember, that's that. Okay? Shifted down 4 units. Looks like I'm doing this in some sort of weird order. 3 to the x and then down 4. Remember, these are separate. That's part of the exponent. These are separate. Shifted left 2 units. Okay, so that's 3 to the x. Now then, what's that one? If I go left, that's plus 2 in the exponent. Reflect about the x-axis. Again, that's just going to give me negative 3 to the x. About the y-axis, that's 3 to the negative x. And hopefully all those are okay. Okay? Now, something like this just means plug negative 3 where x is. So I've got to have to do this. Half multiplied by, right, 1/4. It's just this base, okay, that's got the negative 3. And I'm going to add an 8. So I have to do this first, okay? Didn't do that half yet. Like 4th to the negative 3. 1/4 to the negative 3. Actually, 1/4 to the negative 3 is the same as 4 to the positive 3. Okay, think about it, because I turned it upside down. Well, that is 64, okay? That there is 64. Okay, now then, I'll put it up here. That there's 64, okay? If I half 64, that's this part here, that is, what's that, 32. Then add the 8, that is 40. So again, not too bad. Just think about what you're doing, don't make any mistakes. Now then, this is a kind of interesting question at the bottom. I will actually just answer this. Sometimes I don't bother doing these calculation ones, especially as it's not part of the homework. But what role does the horizontal asymptote of an exponential function play in telling us about the end behavior? Well, here we go. If I just do, okay, if I do a horizontal asymptote, so just leave it as, I'll do the original. I'll do something like 2 to the x, okay, 2 to the x. Now, you can see the horizontal asymptote here is telling us that as x, okay, as x goes to negative infinity, then f of x, or y, is going towards 0, because the horizontal asymptote is y equals 0, okay? So it just depends on what the horizontal asymptote is.